Hello, what's going on, Grecians? Welcome back to another episode of The Scientific Mind. This is Sir Eman, and today we are going to discuss about energy sources. But before that, it's always necessary to start our day with a prayer. Okay, so if you are ready to listen and learn new knowledge, let's begin now the discussion. Energy resources. Fossil fuel. Natural sources of fuel that form through geological process. They have been used as sources of heat and medicine by early civilization. They remain as primary sources of energy until today. Deposits of organisms or biomass that are primarily used for regeneration. They are formed millions of years ago. They form when the remains of organisms are buried under layers of sediments immediately after they perish. Fossil fuels could form because of the remains of different organisms experience only little to partial decomposition. Fully decomposed remains turn into humus instead. As these sediments build up, heat and pressure increase, prompting changes in the biomass. Finally, the remain converts to the final form of fossil fuels. Coal, crude oil, and natural gas are different types of fossil fuels. Let's talk about these different types of fossil fuels. First, we have coal, then crude oil, and natural gas. Coal. Coal is a rock-like material made from plant matter that live in swampy areas and is widely used as a fuel. Crude oil is unrefined petroleum extracted from the underground reservoir. It can be treated to form other products such as gasoline, plastics, and tar. While natural gas are naturally occurring hydrocarbon gas made up of methane and other alkanes such as butane and propane. Natural gas can be used as fuel for cooking and regenerating electricity. Crude oil and natural gas are from marine organisms. Now let's talk about the formation and the types of coal, the first type of fossil fuel. We have peat, lignite, bituminous, and anthracite. Let's tackle about the peat. Peat. Peat is an accumulation of plant organic materials that only partially decompose due to exposure to water and carbon dioxide. It is recognizable due to the evidence of plant remains and water. Peat is quite unconventional to use because it needs to be dried out and it produces large amount of smoke. Second type is lignite. Lignite is formed when increased pressure from sediment transform peat. It still has traces of plant remains. It is abundant but used only when more efficient fuels are unavailable. Third type of coal is bituminous. Bituminous forms when even more pressure is applied to lignite. No trace of plant materials can be observed in this stage. It is the most abundant form of coal and major source of heat energy. The last type is the anthracite. Anthracite is the last stage of coal formation. It has the hardest consistency among the stages of coal. This form resulted from extreme pressure and high temperature on the layers of sediments. Anthracite is born with a short flame and only produces a little smoke. Next, we have crude oil formation. Crude oil formation has 4 stages. The first stage is when marine plants and animals gather energy from the sun and their food to increase the organic materials in their body. When they perish, their bodies sink under the ocean. Second stage, the remains of the marine organisms are buried under sediment as time passes. Third stage, more sediments bury the remains of marine plants and animals. These sediments turn into sedimentary rocks after a million of years. The last stage, the heat and pressure from the sedimentary rock slowly turn the plant and animal matter into crude oil. Some of the crude oil migrate in porous rocks, while others remain trapped in impermeable rock reservoir. After crude oil is extracted, it undergoes different process of refining. The most widely used method to produce crude oil is fractional distillation. Crude oil produces different oil-based products by being heated and vaporized at different temperatures. Gas, gasoline, kerosene, diesel oil, fuel oil, tar, and paraffin wax are all produced when crude oil undergoes fractional distillation. Processing of crude oil also yields byproducts such as petroleum jelly, fertilizers, vitamin capsules, and others. Crude oil is the most commonly used source of energy in the world. Formation of natural gas. The first stage is when microscopic plants and animals from the ocean die and sink to the bottom of the ocean. Sediments, plants, and bacteria forms layer above these organisms. Second stage, heat and pressure increases as the remains of these organisms are buried deeper by sediments. A biomass made from plant materials and exposed to greater heat produces natural gas. Third stage, natural gas migrates through the pores in the rocks. Some escapes to the Earth's surface while others are caught in impermeable rocks and clays and become trapped deposits of natural gas. There are problems encountered with the use of fossil fuel. Oil-producing and exporting countries are aware that the fossil fuel supply may not last long. Fossil fuels are non-renewable and finite resources because of the extensive process of their formation. Here are the several problems faced on the usage of fossil fuel. First, the dependence on fossil fuels may cause problems in the long run if the supply is inadequate. The extraction of fossil fuels has also caused different environmental problems like damaged land. Coal mining disturbs the ecosystem of the terrestrial land. The extraction of crude oil and natural gas requires structures that affect the marine locations. Workers in coal mines and crude oil refineries experiences health problems such as lung disease. The use of fossil fuels as a source of energy has produced great amounts of gaseous waste such as carbon dioxide, methane, and nitrous oxide that have contributed to global warming. Transportation of crude oil can lead to oil spill that negatively affect marine life. Tapping energy resources. Aside from non-renewable resources like fossil fuels such as coal, crude oil, and natural gas, there are other sources of energy. We have the geothermal energy, hydrothermal energy, wind energy, solar energy, and so on. How these renewable energy resources are being tapped. Geothermal energy. Geothermal energy is one of the natural resources utilized to generate power. This form of energy usually thrives in volcanic areas such as the Pacific Ring of Fire and Iceland. It comes from the heat that is produced inside the earth. Geothermal power plants utilize the steam or heat from the earth to generate electricity. High temperatures vaporize water and turn it to the steam. Steam is extracted because it has the energy to turn turbines in power plants to generate electricity. How electricity is generated from geothermal energy. First, groundwater reaches the areas near volcanoes. The molten rocks around the volcanoes heat the groundwater. Second, people reach the heated groundwater by drilling wells to the ground. Steams may be directly extracted from the well. If only heated water is available, the pressure is decreased to convert water into steam. Third, the steam and water harvested from these wells are separated. The water is released back to the reservoir for the generation of. The steam is sent to power plants. The steam spins the turbine that generate electricity. The steam is condensed into water and returned to reservoir. Types of geothermal power plants. There are three types of geothermal power plant. First, the dry steam power plant. Next, flash steam power plant. And the last is the binary power plant. Dry steam geothermal power plant. Dry steam power plant harnesses energy directly from the steam ejected. Dry steam power plant harness energy directly from the steam ejected by the geothermal source. Steam from underground goes through pipes and directed to turbines. Flash steam power plant use heated energy Flash steam power plants use heated water more than 180 degrees from the resource. When the water reaches the surface, a separator segregates steam from water. The steam is directed to the turbines. Binary power plants use both heated water and solution with a low boiling point. The heated water causes the solution to turn into steam. The steam of the solution is used to generate power from the turbines. Advantages of using the geothermal energy. First, geothermal energy is clean and renewable. Since the heat of the geothermal energy comes from the earth, only few chemical pollutants are released into the atmosphere. Pollutants are only expelled if the construction of geothermal power plant is incorrect. Only few wastes are generated by geothermal energy extraction. One of these wastes is water, which is actually reverted back to the geothermal source to be reused. Energy from geothermal sources is low in cost and maintenance. Fossil fuel plants cost much higher than geothermal plants. Last, geothermal power plants do not need a large space to be developed. Since geothermal energy has its advantages, it also has disadvantages. First of it is geothermal energy emits water vapor into the atmosphere. Large amount of water vapor can cause greenhouse effect. Second, geothermal energy is affected by temperature drops in a location. In this case, it becomes an unreliable source of energy. If too much water is pumped to the geothermal source, the molten rocks may be cooled off. Third, some harmful gases may be emitted by geothermal resources if the source is not managed. Remember that these resources are near volcanoes, so there is a high tendency of ejecting volcanic gases such as sulfur dioxide. Geothermal energy can only be used by the location surrounding a source. It cannot be transported for long distance. Next is hydroelectric energy. Hydroelectric energy is produced by the force of moving and flowing water. It is harnessed from water sources that have tendencies to flow or to fall from a certain height. This energy depends on the water cycle for replenishing resources and the kinetic energy from the flow or fall of water. Hydroelectric energy is widely used as an alternative source of energy worldwide. How electricity is being harnessed to form energy. The ideal source of hydroelectric energy are large, fast-flowing rivers and waterfalls. The two main factors considered in selecting a good source of hydroelectric energy are the flow of water and the height difference between the water source and outflow. Reservoirs such as dams are built on rivers that have high potential energy. Reservoirs increase water height and enable the water to be controlled. The water from the reservoir is channeled to the turbines in hydroelectric energy. The water from the reservoir is channeled to the turbines in hydroelectric plants. The release of water is controlled through the intake or inlet gates. When the inlet gates are opened, the water flows through into the penstock until it reaches the turbines. The penstock is a large shaft that connects the reservoir and the power generating units, the turbines and generators. The energy from the flowing water turns the turbines that are connected to electric generators. The turbines produce energy that spins electromagnets on the generators. The movements of the electromagnets produces current. The current is now transferred to transformers through a long-distance power lines or transmission cables that store or distribute electricity. Water flows out of the turbines to river or to other nearby water resources. There are three types of hydroelectric power plant. First, impoundment. Next, diversion. Last is pump storage. Impoundment is a type of hydroelectric power plant that needs a reservoir for operation. Water released from the dam flows through the turbines. One advantage of this design is that water can be controlled depending on the electricity or water needs. Diversion is also known as the runoff river. Diverts some portion of a river through a small pipe or the penstock. The weir or a small pond is required to keep the penstock submerged. The channeled water goes straight to the powerhouse and turns the turbine to generate electricity. Last type of hydroelectric power plants are the pump storage. Pump storage is like a battery that stores electricity. It has two reservoirs built, the top and the bottom. It stores energy by pumping water through a lower reservoir to a higher reservoir. When electricity is needed, the water from the upper reservoir is released to the lower reservoir to generate electricity. When electric demand is low, the water in the lower reservoir is pumped back to the upper reservoir for use. Advantages of using hydroelectric energy. Hydroelectric energy supplies a large part of renewable energy generated in the world. It has advantages that make it viable alternative for electricity production. Next advantage of hydroelectric energy is that it relies on water. As long as the water cycle is happening, hydroelectric energy can continue providing water. Next, hydroelectric energy is renewable. Since water goes back to its resource through the water cycle, water can be used again and again. Hydroelectric power plants are safe. They almost have no pollutants released. Hydroelectric power is not limited to the generation of electricity. This means that electricity generated from power plants can be stored for future use. Last, hydroelectric energy provides affordable power, especially to rural areas. These are the disadvantages of using hydroelectric energy. Hydroelectric energy is not a perfect source of energy. Some processes involve harnessing energy can also cause some disadvantages or even harm to the people and the environment. First, reservoir can become obstacle to moving fishes. In some locations, fish ladders are installed to help fishes in their movement. Next, dam cause floods to river. The flood destroys the habitat of some animals and plants. Animals are forced to move to other places because of this. Turbines and generator can increase the water temperature. This event could cause distress to the plants and animals inhabiting the water sources. Fourth, people living near the water sources are forced to migrate because of the change in the landscape. This affects their livelihood and culture. Fifth, hydroelectricity may be cheap for the consumers, but it requires high investment for the structures. Next, water resources. Water can be found in different locations worldwide and takes diverse form. Recall what your world map looks like. If you point at a random place on the map, your finger will have a higher chance of landing on an ocean than on land. This is because most of the water on Earth is found on oceans. The oceans account for around 96.5% of all water on Earth. However, water in the oceans is salt water. It cannot be used as drinking water for animals and plants because of its high salt content. But one might ask, why not extract potable water from the salt water? Only 2.5% or 2.5% of the Earth's water is fresh water, and only 1.2% is surface water, or accessible to humans for use. Most of the fresh water are contained in the glaciers and polar caps found in the North and South Pole. It holds 68.7% of all the fresh water. On the other hand, 30.1% of the remaining fresh water is a groundwater, the source of water of springs and wells. Groundwater can be found by digging through the soil and finding the water table, which is the boundary of an aquifer. Not all people can utilize this source. Surface water can be mostly found in ground ice and permafrost, which is 69%, and 20.9% which is found on lakes. The rivers hold a small portion, which is 0.49% of the surface water, but they are our major source of water. Fresh water can also be found in the atmosphere in the form of water vapor, as well as in living things that makes up 0.26% of the total surface fresh water. Other forms of fresh water come from swamps and marshes, which is 2.6%, and 3.9% accounts for soil moisture. That's all we have for today. I hope you learned new knowledge about energy sources and how these energy sources are being tapped to be used for human consumption. Again, this is Sir Eman of the Scientific Mind. See you on next episode.